Chapter 5.9, Inverse Trigonometric Functions Integration. Yesterday, we saw how to take the derivative of an inverse trig function. So arcsine, arcsecant, arccosine, arccosec, arctangent, arcotangent. We took the derivatives. Well, today we're going to start with the derivatives and see how to work backwards. It's a lot like the other trig functions. If you have cosine, which function has cosine as derivative? Well, you work backwards, it's negative sine. We're going to do the same thing. Which function has du over the square root of a squared minus u squared as its derivative? Well, working backwards, we saw yesterday that arcsine had that as its derivative. So we're going to start with the derivatives and work backwards today. It's kind of nice in the fact that there's only 3 instead of 6. Whenever there's a negative, the negatives involve the cofunctions. We just pull it out, and instead of saying arccotangent, we'll have -1 over a arctan, and so on. So let's do a couple examples. Because really what it is, you need to recognize the pattern and simplify. Right? So let's take a look at this problem. Which pattern follows dx over the square root of 4 minus x squared? Well, if we go back and look, that appears to be very similar to right here. All right? And so that was du over the square root of a squared minus x squared. And that pattern was arcsine of u over a plus a constant. And this follows pretty closely, provided that a represents 2. There should have been a u. A represents 2 and u represents x. We can then fill it in and we get arcsine of u over x. U is u over a. U is x, a is 2, plus a constant. And you can always check by taking the derivative. All right, the next one, which one follows the pattern dx over 2 plus 9x squared? If you take a look, there's only one that has addition in it. It's that one. So if we come back, the pattern was du over a squared plus u squared equals 1 over a arctan of u over a plus a constant. So we'll take a look. This follows a pattern provided that a equals the square root of 2, because if you look, a is in that spot, or a squared is in that spot. And u is 3x, because u squared equals 9x squared. Okay? We follow the pattern, we get 1 over a, which is the square root of 2, arctan of u, which is 3x, over the square root of 2, plus a constant. Some places they're going to want you to rationalize, so we'll rationalize this quickly. 1 over the square root of 2 will become square root of 2 over 2. Arctan of 3 square root of 2x over 2, plus a constant. So it's looking for the pattern and simplifying. See what substitutes in and fill it in. Take a look at this one. Right? Which one follows that pattern? Take a look, go back. Might be helpful if you copied this table down so you didn't have to keep going back and forth to it. Right? That's the one. Right? And so the pattern was du over u square root of u squared minus a equals 1 over a arcsecant, absolute value of u over a plus a constant. All right? That holds true as long as u is 2x, a is 3. Sorry, I copied the problem down. It should be a squared. Yep, a squared. All right? Slight problem, though. We need u to be 2x. We need u to be down here, so we need this to be 2x. Well, I'm going to make it 2x. However, that changes the problem. If I multiply the bottom of a fraction by 2, I can balance it off and change it back by multiplying the top by 2. So I'll do that. And now it works. I got 2 out front, and then it's 1 over a. A is 3, so 1 over 3. Arcsecant, absolute value of u is 2x, so absolute value of 2x over a, which is 3, plus a constant. You may want to clean this up a little bit, depending on what's requested of you. 2/3 arcsecant, absolute value of 2x over 3, plus a constant. All right? A couple more examples. All right? As you take a look at this one doesn't really fit any of the patterns perfectly. Looks kind of like one, but not really. Well, what we want to do is we want to substitute. So let's substitute. We know we want squares in there. So what can I let u be so that we have a square there? Let's let u equal e to the x. All right, if that's the case, then du equals e to the x dx. All right, that doesn't really help us because that gives us too much information for our dx. So let's do a change of variables. Let's solve this for x. So we get the natural log of u equals x. Now differentiate. So that gives us du over u equals dx, and now we can substitute. So this gives us dx is du over u, square root of u is e to the x, so that'd be u squared minus 1. That looks a lot like arcsecant. All right, so let's look at the arcsecant pattern. The arcsecant pattern is du over u square root of u squared minus a equals 1 over a arcsecant, absolute value of u over a plus c. Well, it's almost exactly the same, except instead of having a, we got 1. Right? So just go through, let a equal 1, and fill it in. 1 over a, 1 over 1. Arcsecant of the absolute value of u, well, u is e to the x, so arcsecant of e to the x over a, which is 1, plus a constant. And you don't need the absolute value because e to the x is always positive. 1 over 1, you don't need that. Everyone knows what that is. All right? Let's try another one. Let's look at this one. All right? This one kind of has 2 things up top. What have we done every time we had 2 things up top? Well, we split it. So let's split this into 2 fractions. So we got x dx over the square root of 4 minus x squared plus 2 times dx over the square root of 4 minus x squared. All right? Now, the left one doesn't fit any of the inverse trig patterns. But if I look, the degree on the bottom, u equals 4 minus x squared, that will differentiate to something similar to what's up top. All right? Very similar. It's not exact, but I can make it exact by multiplying by -2. I, of course, have to balance it by multiplying by -1/2. The second integrand, that looks very much like the sine one. If you remember the sine was du over the square root of a squared minus u squared equals arcsine u over a plus a constant. All right, and you can see if a equals 2 and u equals x, that fits. All right, so let's do those substitutions. All right, here we're going to end up with -1/2. The square root of u on the bottom, so u to the -1/2 du, plus 2, we can go straight to the arcsine there, 2 arcsine of u, which is x over a, which is 2, plus a constant. All right, we will continue. The antiderivative of u to the 1/2 will power up to +1/2, multiply by the reciprocal, so -1/2 times 2 is -1, plus 2 arc sine of x over 2 plus a constant. And now all that's left to do is to put our u back in. So negative square root of 4 minus x squared plus 2 arc sine of x over 2 plus a constant. And so all that's left to say is make sure you remember your integration rules. Look at them, find the pattern that fits. And I'll end on this screen for you so you can just kind of look at them.